So today let's take a look at this power factor saver. It's one of those magic power savers or electricity saving boxes from eBay, which promise you to save you 30% or more of your electricity bills. But of course in reality those are just dodgy scam devices which don't do anything other than lighting up an LED and maybe connecting a capacitor in parallel to mains. So let's take a look at this one. It's called Power Factor Saver, not just Power Saver, and it's easy and simple, okay? Just plug in. Some description on it. Save up to 30% of your electricity consumption. A breakthrough in technology, of course. World's smallest compact design and strongest power. And a lot of text here, if you want to read it. With no reflections, of course. And some pictures on it. And it shows how it's meant to improve the sine wave of mains and to also reduce the current and bring it into sync with the voltage. Here the current is lagging after the voltage, which means that it's an inductive load. And here it's compensated. So it's probably just a capacitor in parallel to mains. And now let's take a look in it. There's some manual and it's in some posh looking plastic bag, which looks like those biodegradable bags or just an imitation of it. And here's the label on it, technical parameter, some type number, voltage range, frequencies, 28,000 watts, useful load. That's amazing. Another number and electricity saving spike buster. And it has a European plug and something here. Intelligent energy saver electricity saving box. The result is the best. Nice. Adapt the latest and high-efficient technique of Germany to save electricity. Interesting. And of course those manuals are always amazing. Joyce's surge forward you at heart. Do not forget, the electricity saved box brings you happiness. Don't be too rude. And of course, please don't open. So let's open it. Or maybe let's try to plug it in first. It has a European plug, so let's plug it in and there is an LED which flickers in camera but not in reality or not so much. It seems to be a 50 Hz flicker, 1/2 cycle rectification and no smoothing, and it goes into some LED. There is a green filter but I can see a white LED behind it. Let's try to measure how much current does it draw. 0.16 amps. So let's do the calculation and the apparent power of it is 38 volt amps. The mains voltage times the current. But the real power of it, measured using my DIY wattmeter, is almost nothing, and the 10 times more sensitive socket, about 0.65 watts real power. So it basically draws quite a lot of apparent power, but in comparison very little real power. So it seems like there is a capacitor in it. Now let's try to calculate the capacitance of the capacitor in it. A capacitive current is the voltage times Q times pi times the frequency times the capacitance. And so the capacitance is the current divided by the voltage times Q times pi times the frequency. And this is the current, here's the mains voltage, Q times pi times 50 Hz frequency of my mains, and this is 0.0000028 farads or 2.28 microfarads. So it seems like the capacitor could be 2.2 micronominal. But now of course let's take a look in it. There seems to be a screw, let's unscrew it. And that's it, and it opens. And yes, there is probably a capacitor and a tiny board on one screw. So let's explore the internals a bit closer. The mains basically goes into a tiny board with a fuse, several resistors, an LED, and there is this capacitor and some foamy tape so it doesn't rattle in the box, and here's the screw, so let's unscrew it, and something from the other side of it, a diode here which is botched onto it horribly from the other side of it. Nice. I'm not sure why this diode is from this side of the board, and it seems to be quite botched because there are resistors but the board says diodes, and the symbol actually shows the cathode of a diode here, here and here. And here's the schematic of it, and the mains comes in, there is a fuse, the capacitor and some resistors. Those series resistors, this parallel resistor, probably a discharging resistor for this capacitor, and another series resistor, and the LED, and this anti-parallel diode. And the schematic doesn't make much sense. Well, there is this 100 kilo ohm resistor in series with those LEDs, but those low resistance 100 ohm resistors don't make much sense. The resistance of those is absolutely negligible compared to this one. So it seems that those resistors are just used as jumpers. And this resistor is a discharging resistor for this capacitor, probably, but it should have been probably here, not here. And of course this capacitor mostly discharges via the LED and this diode, because this path has much less resistance. And this discharging resistor is only useful if this LED or this diode or this resistor go open circuit. And of course this schematic is very similar to the other energy saving box I already opened, but the other one had a green LED instead of a white one, as far as I remember. And now let's try to measure this capacitor. Let's try to remove it and let's explore it. It should be discharged via the resistors, but let's discharge it anyway for safety, and let's try to measure it using my capacitance meter. And the capacitance of it is 2.4 microfarads. So my calculation was close. So that's it. This magic energy saving box is just a capacitor in parallel to mains and some indication LED. And of course it doesn't save any power. It actually draws some power because of the LED and the series resistors. Of course the capacitor is meant to compensate the inductive loads, but the first thing is that households usually don't pay for inductive loads, and the second problem is that nowadays you don't have much inductive loads in your household. You're more likely to already have more capacitive loads like capacitive droppers and interference capacitors. So this one can make the household even more capacitive. Inductive loads like traditional iron transformers or fluorescent fixtures are slowly disappearing, and on the other hand, you have more and more devices with capacitive droppers or switching power supplies with a lot of interference capacitors in parallel to mains. So it's very likely that households are already on the capacitive side, and this one makes it even worse. And electricity meters in households only measure real power, not the capacitive or inductive one. So there is probably no point using this. It actually just draws some power. But it has a nice box, I could build something into it. So it's a nice night light, very dim one, and it doesn't need this capacitor. But of course the LED flickers at 50 Hz and it's visible in a camera. What if I manually change the setting of the camera, the shutter speed? Now it's 1/30th of a second and it flickers. 1/40th, 1/50th of a second and it doesn't flicker. 1/60th, 1/80th, 1/100th of a second or more, and it flickers horribly. Let's go back to 1/50th of a second. You can basically change the shutter speed of your camera to compensate for the flicker of mains or some multiplex of a display or screen. So this is Diagon Wild, and see you in my next videos, and thanks to all of my patrons on Patreon. I really appreciate your support. And of course you can also become my patron to support my channel and get early videos. And the fluorescent tube flickers at 1/40th of a second, but it doesn't flicker at 1/50th of a second. 1/60th, 1/80th, and 1/100th. And interestingly, when the shutter is 1/100th of a second, the fluorescent tube doesn't flicker, but only the ends of it flicker, because basically the entire tube flickers at 100 Hz, but the ends of it flicker at 50 Hz. 125th, 160th, and it flickers again.